of 0.05. Rule number 1, Vy and Izz are what? Constant. Drop these two. Yes or no? Okay. That's why it's so important to understand the fundamentals of the approach. So now you have Qz at point A divided by T, and this is Qz at point B divided by T, divided by 0.05. Where the problem comes now is Qz is dependent on T. Qzb is also dependent on T, yes or no? Right? The only part that is not affected by T is where? Is this top part. Right? Okay. Now we are going to find Qz at point A. Okay, Qz. So Qz at point A, we have to take the top part. So we calculated before. So this is Q top or Q top flange. Then you must plus. Okay. So the width, not a clue. Depth, we know. Y bar. I forgot the two. Left and right. The width, the depth. The Y bar is equal to what? 20 plus by 30 divided by 2. We calculate Q top of the flange earlier. Q top of the flange is equal to 27.5 times 10 to the power minus 3. I'm thinking, should we change to? No, I think we're still okay. So 27.5 times 10 to the power 3. Is it times 10 to the power 3? Let me check. 27.5 times 10 to the power 3. Okay. Now, why we can use millimeter over here? Because the top is in millimeters cubed. The bottom is also in what? Millimeters. So it's okay. Okay. And then you have plus calculator now. 20 plus 15 times by 30 times 2. So it's 2100 T. Okay. So there's your Qz at point A. So we are good to go. Okay. Yes, ma'am. No, you don't change. The question don't allow you to change that thickness at all. Wall thickness, you know. No, no need to change to millimeters. Why? Because the top is millimeter, bottom also I'm going to look at millimeters. Okay, wait. Silencio. What is your question? 0.05 on the right side. Oh, yeah, she's right. Okay, this is equal to 50. Thank you. 1 pint of beer. So from here, we are going to consider Qz at point B. And Qz at point B is equal to 27.5 times 10 to the power 3 plus by 2100 T plus by the width that is 50, the depth that's 20, and the Y bar is equal to 20 divided by 2. Okay. So this is equal to 50 times 20 times 20 divided by 2 plus by 27.5 power minus power 3. So it's equal to 375 or 37.5 times 10 to the power 3 plus by 2100 T. And then finally, all you need to do now is do this 27.5 times 10 to the power 3 plus by 2100 T. And this thing divided by T. And this whole thing will be equal to 37.5 times 10 to the power 3 plus by 2100 T. And then you divide by 50. Okay. You rearrange a bit, you get 27.5 times 10 to the power 3 plus by 2100 T. And this will be equal to 37.5 power 3 divided by 50. It's equal to 750 T plus by 210 divided by 50, 42 T squared. 210 divided by 50, 42. Yes, sir. Oh. I'm going to lose money today. You're right. Okay, you're right. Well caught, okay? So when that's the case, okay, you're right. Because I look at my answer, it's like, crap, it's different. Well done, okay? So it shows that you guys are on top of your work. So this is equal to 13.75 times 10 to the power 3 plus by 2100 divided by 2, 1050 T. Okay. So from here, you have 42 T squared minus by 420, not 420, 750 minus 1050 minus by 300 T. And then minus by, is it minus? Yeah, 13.75 or 13.75 times 10 to the power 3, and the whole thing is equal to 0. So you can solve this using your calculator. Okay, so T will be equal to 300 plus minus 300 squared minus by 4 multiplied by 42 multiplied by minus 13.75 times 10 to the power 3, close bracket, divided by twice of 42. You all know how to solve this using your calculator, yes? Right? No? If not, you just do this, okay? Nothing difficult. So 300 plus or minus 4 times 42 times 13.75 power 3. 4 times 42 times 13.75 power 3. 300 squared plus by, and then square root the whole thing is equal to, hey, wait, 4 times or 42 times plus by 300 squared, square root this. So it's equal to 1.549 times 10 to the power 3 divided by 84. So this is equal to 300 plus by 1.549 power 3 divided by 84. 22.012 millimeters. 300 minus 1.549 power 3 divided by 300 minus 1.549 power 3 divided by 84, or minus 14.869 millimeters. Okay. So the correct answer is what? It's 22.012 millimeters. Yes. No, I twice the 2T over here already. Where are you? Are you the one that tell me 2T is missing? Lucky I never give you $20, so now I'll be taking back $20. You cheeky sort. You frightened the crap out of me, and you really did. Now you guys are lucky. I show you guys how to do it. On his year, they have to figure out within an hour. Am I right? Right. So now you all know about optimization. Okay, their time. Quite a few students got it also. Okay, quite a few guys got it also. Well done. Okay. Right. Any questions for this? Are we okay? Yes. Left and right. If you look at the equation, the variable cuts across y in this direction. Am I right? It cuts across y. It does not care. I mean, means it's the entire what? Entire length, the thickness over the entire length. If I draw a straight line across with a variable y, you have to consider two thickness because it cuts across two thickness. The solution manual don't show that. The solution manual, sometimes they do it, sometimes they don't. Let's standardize. Let's do it. Are we clear? Okay. Hey, listen. The solution manual is not a very good thing. Let me tell you why. It's not very good is because you are so focused on how they do it. Okay. Just look at their final answer and use the technique that I teach you. Are we clear? Because there are no way from any textbook you are going to get all those 5 rules. Are we clear? So this is like really customized. Okay, you have to really obey the 5 rules that I teach and then solve all this equation. Are we clear? Okay. Yes. So the next thing we want to go for, okay, we're going to look at this problem. If I cannot finish today, I'll finish tomorrow or Friday. So this problem over here, I want to do something further. Okay, so example number 2. Okay, so this is part of the homework. Okay, it's an easier problem. So what I want to focus on is we are going to derive the equation of the shear stress distribution. Okay, we are going to derive the distribution equation of the what? Of the shear stress. Okay. So what we know, okay, what we know is the centroid from the top is 35 millimeters. And given that this is our transformation, okay, given this is our transformation, our IZZ, so is equal to 5.813 times 10 to the power minus 6 meter 4. So we're going to derive the equation of the shear stress distribution. Okay. By looking at the loading over here, if we were to sketch the shear flow or the shear stress, this is what we see. This will be 90. This will be minus 90. This entire length will be equal to what? 180. So from here, we know that our Vmax is equal to what? 90 times 10 to the power 3 Newton. Okay. So the next thing that we're going to do is we're going to derive the equation of the shear stress. Okay. So the equation of the shear stress is dependent on the thickness of the structure. Okay. So we are going to generate piecewise equations that are dependent on thickness. Now, what do I mean by that? Okay. If you look at over here, we know from the top, the distance from here to here is 35 millimeters. We are aware of that. Okay. So the thickness decide the equation. So we have two different thickness over here. One thickness over here is 160. The other thickness over here is what? Twice of what? 40. So we are going to set how many equations? Two equations. With that, I will see you on Friday.